Welcome! Today, we embark on a breathtaking journey into the depths of the universe. Thanks to the incredible discoveries of the James Webb Space Telescope, we'll explore massive galaxies hidden in the darkest corners of the cosmos, galaxies so immense that our Milky Way is merely a speck of dust in comparison. But what do these colossal universe breakers mean? How could such enormous galaxies form so early in the universe's history? Join us on this fascinating voyage as we take a step closer to unraveling the mysteries of the universe. Don't forget to subscribe to our channel and like the video. Yeah, here we go. Black holes are real. We observe them constantly, and they not only exist but also shape the very universe we live in. Have you ever wondered if we are truly alone in the universe, or if there's another dimension to our existence beyond what we see? And what if the James Webb Telescope eventually proves that we're living inside a black hole? Dive deep with us into this mind-boggling, earth-shattering news and discover information that will make you question everything you thought you knew about the universe. So, what are black holes? To start, they are literally the stuff of nightmares. Yes, you may have seen them in science fiction movies, but in reality, they are far more terrifying. According to some scientists, they are simply black holes in space. But the truth is much more complex. Black holes are actually formed by an enormous amount of matter compressed into an incredibly small area. Imagine a star 10 times larger than the sun, all squeezed into a sphere the size of New York City. The gravity is so powerful that nothing, not even light, can escape it. For centuries, scientists have been fascinated by black holes, ever since they began to ponder the possibility of objects in space that could be so massive and dense that they trap light. Some of the most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a small, dense core. If that core's mass is more than 3 times the mass of the sun, gravity wins out. This is a cool and mysterious phenomenon, but when you really think about it, it's also kind of terrifying. So how do scientists detect black holes? You can't just point a telescope at one and snap a picture because black holes don't emit light. Detecting them is a real challenge, but scientists have found a way to infer their existence by observing the effects they have on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will draw that matter toward itself, a process known as accretion. But that's just the beginning. If a normal star gets too close to a black hole, things get dramatic. The black hole can tear the star apart and pull it in. As the matter is drawn in, it accelerates and heats up, emitting X-rays into space. This is how scientists can indirectly detect the presence of black holes. But here's the striking part. Black holes dramatically affect their surroundings. They can consume nearby stars, emit powerful gamma-ray bursts, and even promote or halt the formation of new stars in some regions. It's a truly chilling and astonishing phenomenon. But where do black holes come from? Imagine once magnificent shining stars ending their lives in a spectacular explosion called a supernova. From the remnants of these fallen giants, a mysterious entity emerges, the infamous black hole. But don't let the name fool you. These celestial enigmas aren't just ordinary holes. They're like cosmic vacuum cleaners devouring everything that comes too close. And you know what's really scary? Most black holes are born from massive stars. When these stars reach the end of their lives in a supernova, they leave behind a dark, eternal void. Smaller stars, on the other hand, become neutron stars when they die. Super dense, but not dense enough to trap light. However, when a star is about 3 times as massive as our sun, an incredible possibility arises. Theoretical experts have proven that in the universe, no force can prevent this star from being trapped by its own gravity. Now, that's what you call a devastating fate. As this powerful star collapses, something strange begins to happen. The star's surface starts to approach an invisible line called the event horizon. And this is where things get really weird. Time itself starts to play tricks. From the perspective of someone far away, time near the event horizon appears to slow down. making it seem as though the star's clock is ticking at a different speed compared to ours. When the surface touches the event horizon, time freezes, and the star can collapse no further. It's like a frozen collapse in time, a pretty eerie concept. Scientists have been trying to understand these massive structures for years. In fact, black holes come in two sizes, big and small. But here, small is a relative term. Stellar mass black holes are the remnants of massive stars and can be 10 to 24 times the size of the Sun. It's estimated that there could be anywhere from 10 million to 1 billion black holes just in the Milky Way galaxy. That's an incredible number of black holes that could potentially devour everything in their path. But wait, there's more. Supermassive black holes sit at the other end of the spectrum, and they can be millions or even billions of times larger than the Sun. These exist at the centers of large galaxies, including our own Milky Way. They act like gigantic dark voids, pulling everything toward them. The famous physicist Stephen Hawking spent his life discussing black holes. His lectures were always enlightening, but some of his theories couldn't be verified due to the lack of necessary equipment. However, there's hope on the horizon. One scientific instrument is set to change everything. This device is the James Webb Space Telescope, also known as JWST. Let us tell you, JWST is no ordinary telescope. It's a marvel of engineering, a testament to the potential of human ambition. Sure, we've launched space telescopes before, and they've done their jobs well. But this telescope stands in a class of its own. Even the Hubble, which has served faithfully for years, appears as just a dot in the universe compared to what JWST can do. And this astronomical wonder comes with a price tag of $10 billion. Yes, you heard that right. That many zeros might make your head spin. Bringing this marvel to life required the joint efforts of NASA, the European Space Agency, and the Canadian Space Agency. We also can't forget the valuable contributions from over 300 universities. But we must also acknowledge the risks that come with such a grand endeavor. This is not an adventure for the faint-hearted. JWST is stepping into uncharted territory. NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission duration. Since its launch, JWST has achieved many incredible milestones. It has traveled over 1 million miles, reaching its permanent home in orbit around the Sun. During its journey, the telescope successfully deployed its massive 5-layer sun shield and its giant primary mirror, both of which had to be folded to fit into the launch vehicle. One of the most exciting things about the James Webb Space Telescope is that NASA captured the first images of starlight. The telescope's first image was of a star called HD 86, and it transformed into a mosaic image composed of 18 scattered bright points of starlight captured by the 18 mirror segments in its primary mirror. NASA later released a new, improved image where the 18 unfocused copies of HD 86 were intentionally combined into a hexagonal formation. After the observatory successfully aligned the individual segments of the primary mirror, the image stacking process will begin, bringing those 18 images together to create a clear view. Thanks to its advanced technology, JWST will help explore the early stages of the universe after the Big Bang, specifically the period known as reionization, when the first stars formed. This period refers to the time when neutral hydrogen was reionized, or given an electrical charge again by the radiation from these first stars. This process involves looking billions of years into the past, something only a powerful telescope like JWST can achieve. The telescope will also help in the discovery of exoplanets, planets that are extremely difficult to detect due to the way they interact with their host stars. James Webb's powerful sensors will be able to observe these planets in greater detail, even capturing images of their atmospheres in some cases. Understanding the atmospheres and formation conditions of these planets will help scientists better predict whether certain planets could be habitable. In addition to studying galaxy formation, scientists examine galaxies to see how matter is organized on a massive scale. This helps us understand how the universe has evolved. The spiral and elliptical galaxies we see today have evolved from different shapes over billions of years. One of James Webb's goals is to look at the earliest galaxies to understand how the variety of galaxies we see today formed and how they took shape. But most importantly, The James Webb Space Telescope will help us answer the deepest questions. Are we alone in the universe? And are we living inside a black hole? James Webb has already started pursuing these questions, and guess what it found? Compounds known as polycyclic aromatic hydrocarbons, or PAHs, are swirling around massive, supermassive black holes. These carbon-based molecules are found everywhere, from distant galaxies to comets in our solar system. They are fascinating not just because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet light hits these PAHs, they glow and emit infrared light, which can be detected by James Webb's mid-infrared instrument, MIRI. This light often indicates the presence of young, hot stars nearby. Meanwhile, James Webb may have detected the oldest black hole in the universe, a supermassive black hole that is 10 million times larger than the Sun. By analyzing faint glimmers of light stretching back to the beginning of time, James Webb was able to make this discovery. This dark, ominous find was located in the heart of a small galaxy just 570 million years after the formation of the universe. And astronomers believe that even earlier black holes are lurking in the depths of space. The thought of what horrors might be hiding out there is both fascinating and terrifying. But one thing is certain: the James Webb Space Telescope is giving us a glimpse into the darkest corners of the universe, and what we're finding is incredibly astonishing. The discovery of the universe's oldest black hole has sent shockwaves through the scientific community. This black hole, which existed about 100 million years after the Big Bang when the universe was just 1 billion years old, might be one of many that existed at that time. Astronomers are baffled by the number of these black holes and how they could have grown to such enormous sizes. The researchers who discovered the latest black hole published their findings on the preprint server arXiv, where it is still awaiting peer review. The study's lead author, astrophysicist Rebecca Larson from the University of Texas, believes there may be many more black holes waiting to be discovered. She explained that the James Webb Space Telescope is allowing us to study cosmic history in ways that were previously impossible. Interestingly, some black holes become so greedy that the matter swirling around them heats up and emits light detectable by telescopes. These are known as active galactic nuclei, or AGN. The most extreme AGNs are supermassive black holes, which are billions of times heavier than the Sun and emit light bursts, trillions of times brighter than the brightest stars. To examine these black holes, astronomers use two extraordinary infrared cameras, the mid-infrared instrument, MIRI, and the near-infrared camera, NIRCam. Equipped with these powerful tools, astronomers began scanning the sky. But it wasn't as simple as taking a photograph. They had to decipher the hidden secrets within the light. This is where the camera's built-in spectrographs came into play, breaking the light down into its individual frequencies to reveal information. And there it was, among the faint glimmers from the universe's earliest periods, an unexpected spike in the light's frequencies. It was a chilling signal indicating the presence of the black hole. They realized that the intense heat surrounding the black hole was emitting faint traces of radiation spreading across the vast regions of the universe. But the real mystery persisted. How did these black holes emerge so rapidly during the cosmic youth? This question kept astronomers awake at night. They even tried to discover hypothetical primordial black holes that might have existed right after, or even before, the massive event known as the Big Bang. Yet, no matter how hard they tried, these primordial black holes remained elusive targets. How did black holes come into existence, and how did they grow so quickly? Foundational theories were proposed, each with its own flaws and mysteries. The first theory suggested that these black holes were remnants of stars much larger than any we see today. These ancient stellar giants must have formed incredibly quickly, their births and deaths resembling a cosmic ballet. However, time was a critical factor. The universe was young, and there didn't seem to be enough time for such a rapid process to occur. The second theory painted a different cosmic picture. It proposed that dense clouds of gas suddenly collapsed in on themselves, giving birth to black holes, the insatiable singularities of space-time. This direct collapse scenario would mean that the necessary matter for rapid formation was being fed directly into the heart of darkness. Yet, as always, time was a barrier, here too. As researchers gathered more information, another possibility emerged. This theory spoke of giant stars that exploded during the early periods of the universe, leaving behind a black hole. This black hole rapidly consumed the massive amount of surrounding matter, growing at an unexpected speed. This strange behavior puzzled researchers and raised new questions about cosmic forces. Undeterred by these cosmic mysteries, the researchers formed a powerful alliance and continued their quest for answers. They didn't settle for mere clues. They hoped to unravel the mystery of black holes at the centers of ancient galaxies by searching for strong light signatures. We can only imagine what awaits discovery in the vastness of the universe. But the adventures of the James Webb Space Telescope are far from over. The telescope has detected 6 massive ancient galaxies, dubbed universe breakers, because they could upend everything we thought we knew about the universe. These galaxies date back to a time when the universe was only 3% of its current age, a mere infant. But what's truly shocking is how incredibly massive these galaxies are. They're so large that our Milky Way seems like a mere speck of stardust in comparison. If you want to dive deeper into this topic, don't forget to share your thoughts in the comments. Thanks for watching.